Good morning, we're on to lesson 4, which is Introduction to Sinusoidal Functions. So we're done with the polynomial functions for now. We've kind of crammed 2 mini sections together in this unit. So make sure you're familiar with your polynomial functions, and now we're going to move on to sinusoidal functions. There's a bit of terminology you need to know before we dig into it, so that's what we're going to cover today. So I'm going to draw a few examples and then explain those definitions above there. So basically we're looking at angles now, and what we like to do is we kind of superimpose them onto the coordinate plane. Makes things easier to do with graphing and that kind of thing. So a standard angle, your initial arm will always match your x-axis along there. Your origin will be kind of the vertex of your angle. This is called your initial arm of your angle. Then your angle is going to open up. Angles are how wide something kind of opens up. Follows kind of circular pattern. So I just did an example of 120 to start. So this is my angle here. It's approximately 120 degrees. If you remember, a right angle is 90 degrees. So if I went straight up and down, this one would be 90 degrees. If I kept going another half rotation, another 90, this would be 180 degrees. If I went another 90, this would be 270 degrees. And then a full rotation, this started at 0, but I can rotate all the way back, and that'd be another 90, which will add up to be 360 degrees, which makes sense. If you make a complete revolution, that's 360 degrees, the amount of degrees in a full circle. So when you're drawing your angles, you can actually be pretty accurate looking at this and deciding. So 120 is going to be 90 plus an extra 30, which is about a third of the way across that next section. Okay, so that's my initial arm. This is called a standard angle. The standard angle is an angle between the positive x-axis and the terminal arm, and we always rotate counterclockwise. This is called the terminal arm. It's kind of the end arm. Okay, so that's kind of a standard way of drawing angles on your coordinate plane. Another thing you can have is a negative angle. So the starting point is always the same. Start at the origin. Your initial arm is always matched up with the x-axis. If it's a negative angle, that means you're going backwards to draw it. So I'm going to do negative 70. That means I'm going this way, negative 70 degrees. So I'm going the opposite direction than I usually would. So technically a negative angle of negative 70 is going to be the exact same as an angle, a standard angle of 290. So if you think about it, you could go either way. Negative 70 this way, but if I wanted to look at it this way, it's going to be 270 plus another 20, which is going to be 290 for a standard angle. So those are actually equivalent. Angle of negative 70 is the same as an angle of 290. So using what we know, we can now draw a couple angles. So I'll just do a few of these. I won't do all of them. Let's say I want to draw an angle of 300 degrees. You're going to start at the origin, make sure your line matches the x-axis. I know this is 0, 90, 180, 270. So 300 is going to go all the way around to 270, and I need to do an extra 30, which is about a third of the way across this section. So this angle here is going to be an angle of 300 degrees. And we like to draw this little rotation to show, because this would have been the same as an angle of negative 60, so it just kind of shows you which way you were looking at the angle. Let's do a negative one, so I have negative 120. Starting out, it's the same. But now I'm going negative 120. That means I'm going the opposite direction. So now I'm thinking down to here is 90, and I want negative 120, so I need to go another 30, which is about a third of the way across. So this one's going to be an angle of negative 120. If you think about it, if we wanted to write it as a standard angle, that would be from here to here. It's going to be a 180 plus another 60, so the standard angle would be 240 degrees. So they're both equivalent. Let's look at an example on the next page. I'll do this one here, 410. So again, you have to kind of think, here's 0 degrees, 90, 180, 270, and then it comes all the way back up to 360 degrees. Start with your initial arm. Now we have to go 410, so that means I'm going to rotate this angle all the way around. That's going to take me to 360, and I'll need another 50 to get to 410. So I'm going to draw an angle about 50 further on. This is an angle of 410 degrees. It would match a standard angle of 50 degrees if you think about it. It just rotates around like a clock, one extra revolution before settling down at the 50-degree mark. Okay, so we're going to keep that in mind. That's standard angle measurements in degrees. We have to introduce radians now. A lot of the sinusoidal functions make sense with the radians, and it's just a different way of writing degrees in a different form. So the radian measure of an angle is a ratio that compares the length of an arc of a circle to the radius of the circle. So if you look at measure an angle of radians, is the length of the arc subtending the angle divided by the length of the radius. Okay, so that's kind of a confusing way of writing it, but there's a pattern to it that works. So basically, if you do a full revolution, it takes into account the circumference of a circle. Circumference is 2 pi r. And that's going to tell you how many radians that you have. So a full revolution of a circle is going to be 2 pi radians. So that means halfway around the circle is going to be pi radians, and you can kind of figure it out from there. So I'm going to show a little diagram, and then there's a quick way to actually calculate it as well. So this is what we're used to in degrees. We know this is 0, 90, 180, 270, and then it repeats back to 360. Keep moving along there. If we want to write the same thing in radians instead, which is going to be useful for us in sinusoidal functions, this again starts at 0. If we think about it, the full revolution all the way around, we said already, is 2 pi, so we can use that to figure out what the rest is. So if I want to only go halfway around, it's going to be half of that, so 2 pi divided by 2 is pi. That's how we get that there. If I only wanted to go part of the way from here to here, it's going to be pi divided by 2 radians. And if you wanted to go 3/4 of the way around, what color? If I wanted to go all the way around over to here, that's going to be 3 pi over 2 radians. A pi plus another pi over 2 is going to give you 3 pi over 2. So this is radians. We use it in a similar way as degrees. You'll find in this unit we do almost everything in radians, so it's valuable to be able to convert between degrees and radians. So that's what we're going to practice today. So let's go to the back page. So I kind of filled in that chart already. I'm going to skip that for now. The main thing that you need to know is how to convert degrees into radians and vice versa, how to convert radians back into degrees. So to convert from a degree to radians, all you have to do is multiply by pi over 180, and it's going to convert your degrees into radians. If you want to convert from radians to degrees, you're going to multiply by 180 degrees over pi. And that would have been on your formula sheet as well for your diploma. So let's actually do some conversions. So we want to express each angle measure in radians. So if I'm converting from degrees into radians, you're going to do step 1 here. You're going to multiply by pi over 180. So all of these ones here, you're just going to multiply by pi over 180 degrees. So let's do a couple here. So if I want to convert this one to radians, I'm going to multiply by pi over 180. And we like to keep radians exact. So what I do to solve these is when you multiply it, you're going to get 75 pi over 180. And then we're going to leave it that way instead of actually multiplying it out, because then you're going to have to round at the end because pi is a decimal that goes on forever. What we can do to get the exact amount is just simplify the fraction. So don't forget you can do that on your calculator. So we can go into our calculator, and we have 75 over 180. You type that in your calculator, hit enter, it gives you the decimal, and then don't forget you can go into math and that first option, fraction. and hit enter, and it will write it as a simplified fraction for you. So it's the same as 5 over 12 simplified. So this is going to be your exact radian measurement is 5 pi over 12. If I wanted to write it approximately, then you could actually type it out and go 5 times pi divided by 12 and get the decimal for it. It just has to be rounded. So it'd be 1.309 radians. This is the way we usually use it, but if I ever have it written as a decimal, you know what that means, and it just means it's been multiplied out. So same with all of them, you just multiply by pi over 180. Then, to get your exact form, you're just going to simplify this fraction part. 120 over 180, you're going to get negative 2 pi over 3 as your exact answer. So that's how you convert degrees into radians. Let's go the other way. We're going to have, all of these are in radians. We want to now convert them back into degrees. So using what I put a star on here, you're going to multiply by 180 over pi for all of these. Okay, so we'll just do a couple. These ones you can do straight in your calculator. So I'm going to have 4 pi times 180 divided by 3 pi. If you notice, what's really going to happen is the pi's cancel out. So you basically have 4 times 180 divided by 3. You can type it in either way. So let's do the full way. We'll go 4 pi times 180. And I'm going to divide that by 3 pi. Oh, I think you need brackets around that 3 pi. That's fine. Let's try it again. 4 pi times 180. Your calculator's getting confused, or I guess mine is. Divided by, let's put that back, brackets, 3 pi. There we go. Okay, so you can see that in degrees, this one becomes 240 degrees. So now I've calculated, it used to be in radians, and now I know how many degrees that represents. And the rest are all the same. This one here, you can see they've written it in its, not the exact form, but the estimated form when they rounded it. So 2.5 radians, you still do it the exact same way. If you want to change it to degrees, you're just going to multiply by 180 over pi and just type it in your calculator. 2.5 times 180. And then you're going to divide it by pi. And you'll see that it's approximately 143.24 degrees. And that's how you convert between degrees and radians, and this will come in handy for our next couple lessons on sinusoidal functions. Have a great day.